Right, seems like we're live. Well, hello everyone. Welcome to TGI episode 185. If you are just joining us, feel free to say hi in the chat. It's a bit of tradition to kind of say where you're signing in from. So if you feel comfortable doing so, please do it. We usually have a pretty big audience from all over the world. So good to see you all. Hey, John from Minnesota, welcome, good old friend. Welcome, Cora, also one of our favorite developer advocates out there. Welcome from New York City. Okay, that's great. Cool. Well, I'm David Espejo. If you're wondering why my Twitter handle and GitHub user, etc., it's David Mirror, it's because my last name Espejo, it's Spanish for mirror. So I'm kind of David Mirror also. So I'm David Espejo, your host for this episode. I'm an open source community manager at VMware, where I have the chance to support open source projects and other initiatives. And today I'm joined by two of my wonderful colleagues, Rashid and Washuma, who are maintainers for the Cartographer project. Welcome, guys. Would you like to introduce yourself, please?
Sure. Rashid Abdulaziz, maintainer engineer on Cartographer. And when I get to my part of the show, I'll tell you a little bit more about myself. Over to you, Ashima.
Yeah, I'm Washuma Wanjohi. I'm also a maintainer on Cartographer. I'm looking forward to today, TGIK, a great time to learn new things. And I just learned something new. David, I had no idea that's what your last name meant, nor why your GitHub handle was the way it was. So I know I need to learn more Spanish now.
Cool, got it. Okay, that's great. Yeah, hello, Pete from Minnesota, Olaf from Denmark. That's great. Ian, Sam, hey, from New York City, also Scottsdale, Arizona. Welcome. Awesome. For folks who are just joining, TGIK is a weekly screencast where we aim to learn together by playing around with technologies and tools and the cloud native ecosystem, formerly hosted by some big names in the Kubernetes community. I'm aware I'm trying to fill up big shoes by being a host today. No imposter syndrome at all. Winky, winky. So we'll see how it goes. Right. Remember that. Let me post this here. Remember the show notes are in the HackMD link that I just shared in the chat. The goal is to crowdsource news of the week. So feel free to add news and links to the notes. What we do after the episode is to add minutes and check the notes to GitHub, to the TGIK repo, so everyone can go back and refer to the episode's archives. So without further ado, let's get to the news. Let me share real quick here. Right, share my screen. All right. I hope you can see my screen without issues. That's correct?
Yes, definitely can.
Cool. Thank you. Yeah, I'm kind of new to StreamYard, so I had to ask. Cool. We can review core Kubernetes. The SIG release team is working towards the 1.24 release scheduled for April 19th. And last Friday, the enhancement freeze is in effect since last Friday. One of the interesting things to notice is that 25 enhancements were removed from Milestone. You can track that here in the enhancement sheet. And yeah, majority of the enhancements removed from Milestone are under the SIG node. and some others from the SIG storage scope. Yeah, I was curious investigating, for example, these two enhancements that are similar, providers trying to move in-tree storage drivers to the CSI spec. Why they were removed from milestone if the production readiness review was approved? Well, in both cases where the authors themselves pushing for next release for 1.25. We have some others that also didn't meet the PR process. Remember that this is a process established by the SIG release team to ensure that a new enhancement and new feature is safe to operate in production. Okay, there's a new blog post. This one is interesting because it's spotlight into SIG multi-cluster. It's kind of the transcript of a conversation with one of the members of this special interest group, and all the kind of the origins of the group and priorities, scope, and all of that. So it's interesting. Great. This one is one of my favorites. The Kubernetes Community Office Hours will be on next Wednesday, February 16th. This is a monthly live stream where you can take questions and of experts from the community who will most likely answer the question or will help you after the fact to find an answer. So if you are just getting started with Kubernetes, or if you have pressing questions and you would like to have an expert to give you some clues, this is a good space for that. They don't have access to your clusters, so live debugging is not allowed, but it's useful. Okay, for the cloud native ecosystem, TestifySec, a US-based company, turned the Witness repo into public last week. What's Witness? It's a really interesting feature. It's not a feature. It's kind of a framework or attestation system or engine to verify the integrity of the build process from source to target. It has some interesting features here. Definitely worth it to take a look. It was released like last week. Cool. Cluster API 1.1 released. It has like 24 new features. I'm not a cluster API guy myself, but it definitely looks like a awesome release with a ton of enhancements and new features. So if you're a cluster API user, check it out, please. Cool. The Continuous Delivery Foundation, which is another foundation under the Linux Foundation umbrella, they will have the conference in real life in Austin. It's the first week of June, if I remember right, and the CFP side is down. But the call for proposals or for papers is open. It will be open until next Friday, February 18. So if you are planning to attend or to submit anything around these topics, feel free to do it before the final deadline. And if you want to submit something around Cartographer, just let us know. We can help. Cool. This one is really interesting, at least for me. If you want to break into open source and don't know where to start, turns out that the CNCF has been participating in LFX. It's a program where different open source projects establish ideas or opportunities for mentees to participate in. So if you want, for example, if you have Golang or Kubernetes or CLI skills, you could help the Litmus Chaos project to develop new commands or features for the Litmus CTL CLI, along with integration tests for it. It's there are many opportunities there, 42 to be precise, and the deadline to to apply for them is again February 18, next Friday. So feel free to check it out. And finally, the Technical Oversight Committee from CNCF approved the archiving of the open tracing project. Where are you, my friend? There you go. Well, it's, archiving open source projects, it's not a day-to-day task, but it's the sign of a healthy environment. And in this case, it was because the open tracing and open census projects merged into open telemetry. And it was the original intention of the maintainers to archive open tracing. So it was approved. So it will be moved to the list of archive projects. Right? If you feel that something's missing here, if you have some news, anything to share, just feel free to add it there. As I mentioned, it will be checked into the GitHub repo, so it will live there. Right? Okay, so without further ado, I will move to the intro to Cartographer by my good friend Rashid. Let me stop sharing my screen.
Thank you, David. I will start sharing mine.
Meanwhile, well, we have Alex from Northern California. Yeah, too warm, too sunny. Martin from Netherlands. And yeah, Rashid from Virginia. Welcome.
I know that guy. All right. Hi, folks. So I did say I'd introduce myself a little more. And so in introducing you to what Cartographer is, I thought I'd take the tack of why I'm excited for working on Cartographer. And so around 42 years ago, I wrote my first computer program on an Apple II. And maybe 10 years after that, about 32 years ago, I did my first professional work as a software engineer. And I don't believe in the appeal to authority, but I do have some cautionary tales from years of experience in software engineering. And I think we're all aware of the not built here syndrome, right? There's a specific one, and that is engineering everything, because you must have full control, and your software project, whatever it is a snowflake that cannot be contained by traditional practices. These are stories I've seen and I've been a perpetrator of. I can't use that language. I'll make up some arguments for why you should not use this language or this platform, and it will be because I really like this other one, or this is something that only we can only do on this other one. And these are not uncommon stories. And in my time as an engineer, I've worked for small startups trying to produce something quickly, get it out the door. Worked for small startups who have to work with enterprises and deal with significant bureaucracy in the enterprise. Sometimes necessary, sometimes not. And then there's also the significant bureaucracy that occurs in your startup or your small business, quite often because it's assumed that you need to adopt the at-scale solutions that large businesses use to be as successful as them. So I see a lot of those sorts of things happen. And classically, it would be about needing metal servers, being able to run your product. Well, actually, I'm jumping the gun a little bit there. We used to distribute everything on CD and disk, right? So you wouldn't be able to run your product. Your user would be running your product. And one huge value that came up with the advent of the internet and internet distributed services applications was that you could actually have much better control over versions that your customers were using, because they were connecting to your applications online. They were using online services. And that was a major jump forward. I mean, it really was. And it just meant that you were maintaining not multiple versions and historical versions, maybe 10 years old of your software. You were maintaining the one that everyone could use, perhaps a couple of previous versions, because you were using web services as your way of distributing your product, be it a website or a business service that people could connect to, or both. Monolithic, microservices, it doesn't matter. The thing is that when you were producing those services and you were trying to distribute them or host them at the time, certainly, I'd say going back maybe 15 years at this point, I was still personally working with metal a lot. So working with physical servers, installing software, installing your operating system, installing services to back your applications, databases. You were dealing with DNS, networking, email. You had to configure SendMail so that you could distribute email as part of your web app. As a great example of just a horrible side job that you would have to work out and maintain. And then if your business grew, so typically if you were in a small business, then the developers had to worry about those things as much as they did the actual app they were writing. It's hard to focus on the app you were developing because a lot of your time was spent doing infrastructure. And as those companies grew, you would start to separate. And my experience was with I hired this wonderful guy, Jonathan Hoskin, who came to the company I was working at and started building out our infrastructure, our physical infrastructure, so that we could deploy our applications. And we started to have the same struggle a lot of people had, which was the developers were building applications that worked on their machine, but did not work when we handed it to Jonathan or whoever that person was. You've all got some ops guy at some point who needed to deal with developers' configuration and get it working. And there would be things like Apache configurations or IIS configurations, because you didn't have your own web server. There was a web server that was running the company's applications online, and you would sit behind that. And so there would be certain configurations that Apache would have to match to work just the way that it did on your machine as a developer. And so Jonathan, being a smart fellow he was, realized that he could use virtualization. And he actually had, a couple of Blade servers already set up where we were able to actually deliver him operating system configurations, which were usually done with like Chef or Puppet or Ansible or those style of things, but directly on the semi-metal, so the virtualized metal of those virtual machines. So we're still setting up Apache, and we're still setting up SendMail and whatever else we needed, and making sure that networking was, and firewalls were configured properly. And then we'd finally install the application and make sure all the application's dependencies were installed. And it was around that time, this is before containerization, to my knowledge anyway, Heroku came along with this thing called the 12-factor app. And it was a game changer for us. So I recommend taking a look at 12-factor app. I forget what the URL is. Fortunately, it's not going to tell me unless there we go, 12factor.net. This is a game changer, this site. It's not always obvious that it, I guess in the modern world, how different this was. And that's what I wanted to point out. It's something so different to what we were doing at the time. This is about developing an app, and other technological advancements came along at the same time that made this incredibly easy to do. First of all was the Twisted framework in Python, and then a lot of other languages following suit. Basically, your application and the framework that you're writing against has its own web server and handles web requests. So it took Apache out of the loop immediately. So that was really helpful, because you were now actually talking directly to a web app, and you didn't have to configure like Apache IIS, that sort of thing. And the other, I think, really valuable thing here, and it's all valuable, I encourage people to have a look and understand why this was great, but The other really, really important thing for me was backing services. The idea that that your backing servers are attached resources. It doesn't matter how you get them, so long as they're the right resource. And in the case of Heroku, they actually gave you your backing services. You wanted MySQL, you got MySQL. You wanted, I forget what else they had, memcached, for example, right? It was as a service. And so those configurations were something you separated from your app design. There's a lot more to it, but I think it's a really good start to think about how Heroku push changed the world. So this changed my world. What changed very quickly was, instead of me worrying about all of that, was I would write my application, Rails, quite often. It was versioning at the time. I would write a Rails web application. I would have a script to set up a local version of my database, and I would design my application based, especially with the support of Rails, to be portable, truly portable, not portable on like architectures. We all knew that we're going to target Linux. That's usually what we were going to do. But we made sure that if we had a Linux machine handy, we could definitely run the application. And I would write my app and focus on writing my application. And it was amazing to have all of that configuration lifted off of my shoulders, and to be able to hand this application to anyone in the dev team, them instantly be able to run it, to the operators, them instantly be able to run it, and then deploy it. But they were deployed to Heroku, which didn't work for many reasons. And we'll talk about why Heroku is a bit of a limitation. But first, I'll just talk about that experience. You had your SCM managed repository of code. You added, if you were using Git, you added another remote, which was Heroku, with your own account, the team account, or you would just add Git if you were using a different SCM, and you would push your app. And Heroku would look at your application and say, well, this looks like it conforms to one of my build packs, which is, I think, the core technology here is a build pack picks up your application, and because it's constrained by the 12-factor app, it turns that into a disk image that can be deployed anywhere. We didn't have access to that built image, but Heroku would host it for us. And there are other conventions that made sure we could attach to services. And this might all be very, I don't know, commonplace for you all now, but that was amazing. It was a huge change. Basically, how did I configure my app? I configured my app by writing it the way I wanted it to be, so long as it was constrained to the 12-factor app, and I didn't have to set up configuration variables all over the place, and special cases for different infrastructures that it might run on, because it was going to run in a virtual machine. And so long as I could get it to run that way once, I could continue to get it to run that way. And then containers come along, and they've made that even simpler these days. So now we have that ability with something that's very easy to move around. We don't need a virtual machine to run it on. We can drop it into Docker and do a Docker run. So that was the huge benefit of Heroku. And then Cloud Foundry came along, because Heroku has some downsides. What are some of the downsides? It's publicly hosted. It lacks supports for air-gapped environments. It's backed by private IP. It's not an infrastructure that a company can have full control over. So it's tied to Heroku's physical infrastructure. And it's also quite forceful about its compliance with the 12-factor app. As much as I talk about it, not everyone wants a stateless service-backed application. Some people want services on disk, or they want to use Lambda functions, or there are other ways that you might want to write your application. This goes back to the not built here thing. Sometimes you actually do need to build something here. There is some sort of infrastructure or design that calls for more than what you have today. So Cloud Foundry tried to address some of these things. And I hope some people have seen Cloud Foundry in action, but it goes from the Git push to the CF push. with a little manifest file sometimes to set certain setup variables, configuration variables that are needed to get it started and running. Cloud Foundry also used build packs and extended them. It made build packs available in air-gapped environments so that you could pull dependencies only from within your network to avoid man-in-the-middle attacks. So that offline mode was really helpful. It's largely open source, much easier for companies to adopt and not worry about vendor lock-in. It supported multiple IaaSes, like a lot of them, and generalized internal infrastructure such as vSphere. So you could run it on local machine infrastructure. You could run it on one of the cloud providers. And generally, applications would deploy the same in all of those places, which is pretty epic. I think so anyway. I hope you all agree. But then Cloud Foundry has a few gotchas. I think one of them would be Bosch. It was an infrastructure adapter and it was a good one, but it did not see significant adoption. And it certainly had a learning curve, which was not huge for developers. I don't think it was even all that insurmountable for operators, but I think for platform integrators, people providing services, add-ons and sidecars, it was difficult. And I think that Kubernetes has really taken that place, has become the industry standard. And it's a really good declarative language for a declarative system for describing infrastructure and even where to put your applications. Also, Cloud Foundry represents the last mile effort of your software supply chain. It's simply from source code, built image, deployed. And there's some compliance and control there that's just, it's absent. It doesn't help with ensuring that vulnerabilities are maintained and patched from the software. It did with the underlying images. That was great, but it didn't check the software and ensure that it was continually integrated with new CVE patches. And it didn't support special compliance rules or specialist supply chains, specific behaviors that your company wants to use. It did not support that. It had a very particular path to prod. And that's what Cartographer is trying to...
What about that, Rush?
That's a great comment. I like that one. So Cartographer is now... oops, sorry, I'm on my wrong... Cartographer is now trying to bridge that final gap, give us a way to go from development, being able to build and rebuild your application, much like it would appear in production, which is a huge value add that Heroku's paradigm gave us, but also go through constrained and controlled supply chain to production. That means that operators can collaborate and divide their labor on how to get things built to meet the enterprise requirements or the business requirements, and keep it away from the developer. The developer should still have a very simple manifest to describe their app. Their app should conform in basic principle to whatever build pack we select for, if that's the route we choose to use. There's other ways to build apps. But it gives the operators and your business team the opportunity to ensure that your applications go through a process of ensuring the security, compliance, and I don't know, SOX compliance is a classic example, to go over boundaries from development into staging and into production. And it tries to remain simple in the fact that it uses native K8s objects, which Washuma, I'm sure, is going to explain a little bit more clearly than I have, but it will print out, it will stamp out native K8s objects and follow them instead of being edge triggered when events happen, just looking for changes. So if something produces a new output along your supply chain, other objects that have been watching it will pick them up. And I think that's an important journey. And I think that's the Oh, Carlos asked the question here, Cartographer using BOSH? No, Cartographer is using Kubernetes behind the scenes. It is Kubernetes as a Kubernetes controller. You'll see more of that with Washuma in a moment. And no, there is no BOSH. I think that's the point here, is that we're trying to give that same experience, but make it expandable and use modern infrastructure tooling, especially Kubernetes and native Kubernetes objects to implement the steps along the way. So with that, I think I'll hand over to Washuma. I think he can give you much more detail now.
All right. But I want to make sure. Can everyone hear me? All right.
Oh, yeah.
And now let me make sure that I can share my screen. All right. I'm going to go off script for just a moment because I love that question. Like, oh, is this, Heroku BOSH, what's going on here? And I wanted to make a call out to a presentation that I watched at KubeCon this year that really spoke to me. This is, hold on, I want to make sure that I get his name right, Daniel Bryant of Ambassador Labs. I'm just talking about looking at his dev career and the cognitive load that he was going through. And so, he shows he starts in 2000 and the cognitive load goes up, and then like the cognitive load really dropped, and he made a huge call out to that Heroku CF experience that Rash was speaking of. And then after that, we moved to Kubernetes, and there are so many advantages to K8s, but one of the disadvantages is that it does raise the cognitive load on our developers. And so what we're looking to do is make sure that we keep the power of these tools, keep the dynamicism of this community, and at the same time unlock that amazing dev experience. So let's talk Cartographer. How does it work? Hi, I'm Washuma. I'm a dev, and I like DevOps. And so I've got myself a little bit of code that I've written here. And what I want to do, I want to get this running. I want my customers to be able to hit my amazing Hello World app. They need to hear hello. And so there are a couple of steps that I'm going to want to do. I want to get my source code into my K8s cluster. I want to take that source code and I want to turn it into an OCI image. And then I want to deploy that image on nodes in the cluster that are going to run and serve. And so, the first thing that I'm going to do, I'm the DevOps guy in my organization. I'm going to just do this by hand. And the thing that I'm keeping in mind too is I want to simplify my life, and I want to simplify the life of everyone after me. So I'm making the decision. What I don't want is a lot of bash script that I'm going to have to maintain. I want to find tools that are purpose-built by individuals in the K8s community to do all of these steps that are represented here. Well, I'm doing this by hand, and so the first thing I do is I go out and I find the Git repository custom resource from the FlexCD project. Yes. Oh, let me make this.
Yeah. Yes.
Let me make this a little larger. All right.
There you go. Thank you.
So I'm going to go out and I'm going to grab the Git repository custom resource. I'm going to fill it out, and I know that when I deploy this to my cluster, it's going to grab my source code, and it's going to expose it in my cluster to any other resource that would like to use it. Eventually, it's going to create this status, and in this status, I can see now this URL that's custom for my cluster. I can also see, oh, here's the newest revision on the branch that I specified here. Okay, that's great. Now I want to go on to my next step. I want to build that image. I am going to go to another amazing tool, Kpack Image. If you were not here for TGIK last week, there was a wonderful deep dive into Kpack. We made a call out at the beginning of the show to Cora. You can hear why we are such big fans of her, and she can tell you why we're such big fans of Kpack. Here, I'm going to define my image, and I'm going to take this URL here, and I'm just going to drop it straight into the definition of this specification, into this spec. And once I do that, I'm going to submit it to the cluster. The KPAC reconciler is going to pick it up. The controller is going to pick it up, and it's going to reconcile it. It's going to output a status. It's going to tell me, yep, conditions ready, true. And there'll be a new image available. It'll let me know where that image is. And the next thing I'm going to need to do is grab that location, and I'm going to create a deployment. And I'm just going to copy and paste, just as always. Well, and once I do that, I'll be able to expose the ports of that deployment to the outside world, and people will be able to use my app. Wonderful. So I've just solved one problem for one person. I've gotten my code into production. What I would really like is to, one, simplify this for myself. There's a lot of copy and pasting here. And two, I'd like to simplify it for everyone else. Well, the first thing that I notice as I go on that journey is that what I was defining, there's a lot of stuff that's just going to remain the same. You know, the timeouts on this Git repository, I'm not going to need to change that a lot. Some of the definitions of, the failed build history limit, things like this are not concerns that are going to vary by project to project. Those are things that we can really set policy for my entire organization. And that's exactly what I want to do. So what I'm going to do is I'm going to take this resource and I'm going to wrap it in a template. That's going to be here, and I have these fields, and I'm going to then template out those fields that are going to vary. Now, before I dive a little bit deeper into this, I want to, one, step back and say, okay, that's great. I can create all these templates, but really what's my goal? My goal is this file. Rash showed us earlier the CF manifest, and it's 10 lines. And that's our goal too. We want to give developers, here's 10 lines, really simple, that you can submit to the cluster and your app will be available. It's going to go through a defined path to production. It's going to be approved by the experts in our organization that know about operations, and you won't need to care. You push it and it exists. In here, what are the things that I'm going to want to know? I'm going to want to know, where's the source code? We'll talk about these other fields in a bit. So let's go and take a look. Let's jump out graphically and see.
Wishuma, I'm sorry. We have a question. Have you really written all that by hand?
Have I? So this, yes, I've had to write this by hand before. I try not to, but we'll. The whole goal again is that I want to write this once, and then I want to be able to reuse it n times, and I want other people to be able to reuse it n times. I don't want anyone else to do this. That's our entire goal.
Thank you.
So let's come back here and let's talk about what's going to happen. I've shown you these two types of resources that you've gotten a quick glimpse of. One is this workload. The workload is owned by the developer, and it's going to own its own logical supply chain. There's going to be a set of resources, a set of objects that are going to define that path to production. No surprises here. Those are the exact same types of objects that you just saw. It's going to be a Git repository. It's going to be a KPAC image. It's going to be a deployment, right? And then there's going to be an operator who owns the blueprint of all of those things. That operator is going to be doing that write once, use a million times process. They're going to define a supply chain blueprint. They're going to define a set of templates that are called out in that blueprint. And what will happen is whenever a developer submits a workload, that workload is going to pair up with, it's going to be selected by a supply chain blueprint, and the Cartographer controller will start stamping out those resources. As the first object is created, it's almost certain that other objects will depend on it. And every supply chain is different. We're just describing that super simple path to production that we saw here, but it can certainly get more complicated. And at the end of this, we'll be pointing to some resources where you can see how you can iterate forward. You can see some examples of that iteration. So we'll have a resource that's going to be stamped out. Once that resource is stamped out, following templates will say, hey, there are values there that I want, that I'm going to use. And then those objects will be stamped out. And eventually, at the end, you'll have completed your path to production. Each app will have followed this pre-described route to user availability. So that's the high-level view. That's where we're going. Before we jump into the template, there's just one other thing in our documentation that I want to call out. I mentioned there are templates. What does a template look like? At a high level, a template spec is going to have, one, the definition of the template. Makes total sense. Two, there'll be some params optionally, and we'll see an example of that. And three, there'll be some output paths. These are going to be where the author of the template says, hey, that object that you just created, here's what values to expose to the rest of the supply chain. There are a couple of different types of templates, and the templates are typed because different templates are going to be responsible for exposing different values. If you're writing a source template, the expectation is that it is responsible for providing source code or verifying source code. And so what it is going to provide is needs to expose the URL path, the URL and the revision path of that object. Similarly, if you're stamping out an OCI image, you're going to want to specify that resource is going to specify on its status somewhere, hey, here's where the image lives. And so you'll use an image path to define that. So let's dive in. Let's see an example of some of these. There we go. So here we have that Git repository that we were looking at before. And suddenly we can see that those fields that we said can be hard-coded are hard-coded. And these other fields have callouts to the workload object. That's the same workload that we were just looking at here. So we say there's a metadata name, hello. I know that I'm going to, when I apply this to the cluster, when Cartographer gets going on that workload, it's going to stamp out a Git repository with the name hello, because that's what's on my workload. Similarly, it's going to have some value, work, spec, source, Git, URL. You can see that right here, no surprises. And off it'll go. It'll stamp that out. Well, that's great. This one's pretty straightforward. But then suddenly we get down to our cluster image template that's wrapping that KPAC image that we saw before. And we see a little bit of complication. And in particular, I want to draw your eyes down here. In our previous object, we just saw callouts to workload, but now we have a callout to some sources. And right, so far, all we've done is define some templates. How do these templates know which one they're going to talk to? Well, it's that final object that I've just made brief mention to, the supply chain, the blueprint of what the supply chain is going to be. Let's take a look at that really quickly. Here we have the supply chain object, and it has, at the top level, two fields that are super important. One is a selector, because this supply chain needs to define, here are the sorts of workloads that I'm going to work with. And the other is resources. And this is saying, okay, here are the templates that are going to be stamped out. Here's how they rely on each other. Here's how they can communicate. Let's start with the resources. And Rash, David, I'm going to ask you to hold me accountable. Make sure that I come back to the selector so I can talk about it for a moment.
Sure.
Here we have the first step. The first resource in our supply chain, it's a source provider. And this is the name that all the other resources will use to refer to the work that goes on here. And then there's a template ref. No surprises here. It's a cluster source template, and its name is source. And if we go back, I'm sure you'll not be source. Super easy. If you've worked with object references in K8s, this will seem very familiar. That's the goal. So the first thing that's going to happen in the logical supply chain is that it's going to take the workload, it's going to take the values from there, it's going to make them available to this template, and the object is going to be stamped out. Once the next, it's going to go and say, hey, I've got my next resource. It's an image builder. And we see it has another template ref, cluster image template. We have taken just a quick peek at that. It is also providing some values that are going to be made available to that image. First is params, the second, sources. Sources, as we said, there's this name match. We're making sure that at this level, we can pair them up. And then we specify what's the name that the template calls out to this value with. So here we say source. So we've already talked quickly about the fact that a template exposes some values and a source exposes a URL and a revision. Well, as I go back to my demo templated, as I come back here, I can see that my image is now saying, I expect that there's going to be a list of sources that are provided to me. I expect that one of them is going to have the name source. And from that, I want to get the URL. And so there we have that copy and paste that I was having to do by hand. Now it happens by Carto magic. You'll be unsurprised to learn that our next template is going to do much the same, except now the location of the image that's going to be exposed on the status here. Actually, let's make a call out to that. When I was doing that copy and paste, I was going to some field on the object. I saw, here's my KPAC image. It has a status field, and it has a latest image field. And so that's where I was copying and pasting from. Well, now I've put that into code. In my template, I've said, hey, this is going to create an object, and that object will have a status latest image, and that's where you can find the definition of the image location that all the other steps in the supply chain are going to want you to expose. The deployment, you'll be unsurprised to see, makes a call out to that. It says, hey, in the supply chain, there's going to be my resource. It's going to refer to me, the template, and I expect that there's going to be some images provided. And here we see images is providing a solo image, and we make it available. Now, some things when we get to the dev experience, we want to simplify this. Some syntactic sugar that we've made available is you can refer to this by just image because there's only one image being made available, and the image type makes only one field, the image field, available. So rather than images.image.image, you can use that shortcut. But if you want to spell everything out, make it very easy to track, you can use that whole definition. Okay, well, that's how things are being passed from template to template. Another thing that I kind of elided over was that in our supply chain, we saw this field params. So let's go and look at the cluster image template. It does indeed have a field here where we are templating out some parameter. And what this represents is the supply chain, the template author is available to put in. Here is the best information that I have about what I think this value is going to be. And so they say for the params, I'm going to give a value image prefix, and I'm going to provide some default value. And then that parameter value is something that can be overwritten at the supply chain level. Perhaps in this organization, the individual who's an expert at building images that knows exactly how KPAC works is saying, I'm going to defer to the person in operations who's going to be responsible for saying, hey, here's where I want all of the images in our organization to live. And they're able to do that by saying, hey, call out to this default supply chain, and when you want to vary that image prefix value, you can specify a value on the parameter at the supply chain level. In a very similar way, if the operator said, you know what, I actually want to give the developer ownership of that piece, they can just go and in the same way just rename this default, and that allows the developer to define params on that workload. But for now, let's stay here. We're just going to say this is the location of our image registry. Okay, and now that last piece that I was worried that I might not get back to, that I might forget about, cannot forget. How do workloads get matched up with supply chains? Ultimately, it happens based on this selector. We see that there is some label that is expected for the types of workloads that are going to be made by this supply chain. And you can see here some of the philosophy. This is a supply chain that should apply to all workloads that are web apps. And so we expect that your organization is going to have a similar path to prod for all of those different applications. As Raj started out, they're not all special snowflakes. Let's standardize. Let's make things easy for ourselves, make it easy for our operators, because then we can start really honing in on the value at our customer level. So when I go back to my workload, you'll notice one of the fields cannot be forgotten is the label needs to be on this workload, and that label should match some selector of some supply chain that's been applied in the cluster. All right. Now, the last thing that I want to call out on, there are two things. There are two fields that I've not explained on this object at all. One is just some this build env. And here we're just saying, in the same way that there were some variables that we wanted to pass on to objects in our supply chain, for our KPAC image, we're just saying, hey, there might be some build environment variables that we want to pass on. For this example, I'm just saying, hey, for my Go, I want it to be hard linked and specified, easy peasy, ready to go. The last is this service account. We are defining, as I said, we've got this supply chain that can stamp out all these objects in our cluster, and Cartographer would technically be able to create anything. Well, we want to make sure that your organization has the keys to your kingdom, can keep things locked down, locked tight. So your operations team is going to be responsible for make sure that there is some service account that has the rights to create and manage the sorts of objects that are going to be created in a given supply chain. Here we can see an example of that. It's nothing crazy. We've got our service account, we've got a role binding to some role, and here we see that role, and it just says, hey, KPAC, it's going to create an image. Make sure that it can list, create, get, update, etc. Right? As I said, nothing controversial there.
Yeah, sorry, Washuma. There is a multi-part question from Carlos. Carlos Santana.
All right.
Hey, by the way, Carlos, welcome, being a long-time friend of TGIK. So let me put this here. This is one part of the question.
Carlos, you're speaking to my heart. I see him. Well, it's a multi-part question, and I haven't gotten to the second part. But the first thing I heard was, what if what I'm looking for is some GitOps flow, where I'm not looking to push code in my cluster? And I think that said, that makes total sense. In this example, we're not going to get to that, but I'm going to point to resources that describe exactly the flow that you're talking about, because our hypothesis is that, yes, you will want to, or many organizations will want to build in one cluster that has all these resources, that have all this power to analyze code and create images, create images. And then you'll have a separate cluster that you want that's just the public facing cluster that has much less on it. It's just, hey, I've got my Kate's config, I'm going to drop it in there. It's going to serve. So one, David, as I said, I kind of read half the question and I was off on a direction. Have I responded to the question from Carlos, or is there more that?
Yeah.
If there's more question, hit me with it.
I have been responding in line, and I think I've left Carlos and perhaps other people in a position where they believe what I was saying, because I could understand how you would see this, was that Cartographer replaces Heroku Push, and I think I wasn't clear enough there. What Cartographer does is it provides you a way to create Heroku Push-like experiences, short, simple dev experiences, to go through complex but malleable pipelines, or as we like to look at them, supply chains, to get to production. And what we're describing now is how you would architect those paths to production. This is a complex scenario that even the simple one with 3 steps, where there is a lot of templating, but the idea is that it can be reused by all of your developers when you're happy with the structure of it. And what you're doing is at an organizational level, describing the path to production such that developers only have to push their application, but it can go through varied different ways to production. So it's not, Cartographer itself is a way for you to build a platform that gives the experience of CF push, Heroku push. I hope that helps a bit.
Yeah, if not, just let us know, Carlos.
So, and now we get to that fun part. What does that analogous experience look like? We've gone through the work of the operator defining all of these pieces, and congratulations, you guys are all now experts. You can go back to your org and build that logical supply chain. What are your developers going to do? Well, let me bring up my cluster, and I'm going to first just cat my workload. You'll see no surprises here. I'm going to take this and I'm going to apply it to the cluster. So K apply -f workload. Oh, that's our analogous CF push. Take your workload, apply it to the cluster. And now I'm going to just describe this. kubectl get o-yaml my workload, and I know that my workload is named hello. And great, I look at my status and I see supply chain ready. Yep, true. Resources submitted. Missing value at path. Oh no, it's not oh no. This is probably one of the biggest gotchas that folks have. They submit and they expect that instantaneously everything will be done. Well, supply chains take time. If 2021, 2022 has not taught us anything, it's that supply chains can take some time. What's happening here is that we can see there's a value, that latest image, that we're waiting for from our kpack image object. I'm going to go ahead and do a k-tree on the workload. And I can see, oh, look, it's already beaten me. I can see the Git repository object that was created. I made a prediction early on that I'm going to have a Git repository object named hello. Here I can see it. I can see my image object named hello. We've got those names again because that's what the template says. And now that kpack image has completed, and having done that, that final step, that deployment step, has occurred here, and that's ready. So if I do my check-in on my workload again, I can see, yeah, that top level ready condition is true. That's great. I want to hit my deployment. So I'm going to kubectl port forward that deployment there and go forward 8080 to my local machines 8080. And I'm going to swap over to not there, not there. There we go. I'm going to go ahead and curl. Building with Carto is easy. That's the experience that we want to give all of our devs. Well, code doesn't stay static. This is great for today, but what about tomorrow? I'm going to change my code, and I want it to go straight through the same supply chain. Well, all I'm going to do is here's that amazing Hello World application. I'm going to say, I'm glad I spend Fridays with TGIK. I'm going to I'm going to commit this. And I'm going to push it up. Okay. I'm going to stop port forwarding for a moment, and I'm going to take a look at my my tree. What I'm expecting to happen is that my Git repository, that piece that's an expert at checking for updates in a Git repository, is going to notice that change that's been made, and it's going to spin up and it's going to start exposing a new value to the supply chain. The moment that new value is exposed, I'm going to see a new, the image is going to be updated. That image is, because of the way KPAC works, it's going to create a new build. And once that's been completed, the image will be exposing a new value, and it will, the deployment will pick that up. Let's go ahead and see. It looks like that has not been picked up. There we go. So here we can see that new build happening. While that spins, let me take a step back for a moment, because at the beginning I said, sure, it's great. I can create a supply chain for myself, but really what I want to do is I want to create a supply chain for somebody else. So here I want to talk, here I have my friend. I'm sitting here, I'm a Go developer. I've got this Go Hello World app, but I've got my good friend who's sitting at the desk next to me, at the Zoom screen next to me this year. And I want to tell them, hey, I can get your code to production super easy. And they say, oh, no, I'm writing this Java app. It's totally different from yours. I say, no. I've got special built tools. I've got these custom resources that are experts at each piece that they do, and they know how to speak your app's language. KPAC can work with a Go app. It can work with a Java app. So let's go. I'm going to cat out a new workload definition.
Yeah, I'm sorry, Washima. Before that, there's a couple of questions here. First one, about the change you just pushed. Flux will detect the change and update the status of the Git source custom resource?
That is correct, yeah. Let's go ahead and take a look at that Git repository. So the spec has remained the same, and we can see that the last transition time is just a moment ago. Other than saying like, oh yeah, we just saw it occur, I don't know what else to say other than, yes, there's a great resource that's purpose-built for just this.
And also, are these builds Tecton CRs?
No, they are not. We love Tecton for certain things. I love Tecton for making sure that I can run tests, because the tests that I have on my application may well be very different from the tests that I write for a different application. But what I don't want to do with Tekton is write all of that bash to do step 1, step 2, step 3. Step 1 being, get all the things, get all the source code that I need from XYZ place. Step 2, build my image. Step 3, etc. So these resources are I think they are all CNCF projects. David, you may know better, so please fact check me, or anyone in the comments, please fact check me. But these are other resources, other controllers that have been developed in the Kubernetes universe that we find super valuable. Now, all that said, can you work with Tekton? Yes, we love Tekton, and when we go through, we won't get to it today, but in our repo, in our examples, we talk quite a bit about how you can best use Tekton pipeline runs and Tekton task runs in your supply chain. All right,
Cool.
Taking a pause there. If there are follow-ups, please hit us with them. So yeah, I've got, as I was saying, I've got this new workload. It's really similar. This is going to be another web application. It's going to call out to the same service account that's been provided for the operators to say, hey, we know that the supply chain is going to create some objects. We're going to hand you that reference so that you can, so your workload will be able to go at it. This one, build environments, doesn't need to provide anything special to KPAC. And that last piece, that piece that really does vary is, hey, there's some new application at this new URL. So I'm going to apply it. And we'll see that it's going to spin up, and it's going to look quite similar to what we saw before. KPAC's going to work on it. The Git repository having been so quick at its job. While we wait for that to work, let's check in on our previous workload. I see the image repository is ready true. I see the deployment is ready true. I want to kubectl forward again, and I want to see what is being exposed to my customers. They've got their brand new hello world message. They are super happy. As we, I don't suppose, not super quick. So as my friend's Java app spins and creates, I'm going to come back to it. I don't want to take it on my word that this is going to work. I want to just mention very quickly a few things. Here's that Java application. Where do you go to learn more? I hereby certify you. You guys are experts now. You guys know the basics of how to create a supply chain. As you want to move forward in your journey, as you want to hear about how do I do that multi-cluster journey? How do I do work with resources like Tekton that don't have quite the same update mechanisms that other CRs do? That place is cartographer.sh. You can come in, you drop into the documentation. You can see the architecture docs that we've been looking at today. You'll be able to see for each of these custom resources the work that's been put into, just explaining what are all of the different fields, what do they do, what are their purposes, and you'll be able to go on to our examples directory. That's a link here. And this first example, you've essentially done this, source image app. The next place that we recommend that you go is to learn about another custom resource that's part of the Cartographer universe, runnables. And then you'll be able to use that runnable to expand that first supply chain to something that's doing testing with Tecton. After that, there's a quick conversation about how do we then do that GitOps workflow. I want to build I want to build that image. I want to define what that K8s resource is going to look like. But I want to actually deploy it somewhere else. Well, here's where we talk about how do we do that writing to Git, and then how do we use a separate resource, a delivery resource that is a little less powerful, that has just one job: deploy this resource. You can read all those examples here. Behind any product is an amazing team. The resources that I've just been describing have been made by the folks that you see on the screen, and I want to give a big shout out, a big thank you to all of them. And you'll see that there's a big question mark at the bottom, because this is an open source project, and it's going to thrive based on the contributions of the community. We want to put something out there that's incredibly valuable, and anytime you think, you know what would be incredible is if it did X, Y, Z, come talk to us. When you look at the README of Cartographer, there are callouts to when we have our meetings, how RFCs are submitted. We want to engage with you. We want to hear, how is Cartographer helping you? How can it be better? And I want to check in and see. Oh my goodness. Well, I may leave us here just wondering, was Wishuma telling the truth? Is my KPAC image ever going to be built? I have a hypothesis, yes, but I don't want to hold you here for that. So I'm going to hand back to David, and perhaps at the end, when KPAC finishes spinning on that Maven app, I'll jump back on.
Sure, no problem. It wouldn't be TGIK if we didn't have any sort of issue, so no problem at all. Okay, that's great. Thank you. Thank you for joining. Anything else? Anyone else have any questions so far? And yeah, for sure. It's open source. PRs welcome any form of contributions, both code and non-code contributions are welcome. We'll be happy to see you around the community. Let me share here the link for the community resources. And okay, there is not anything else. We would like to say thank you. See you in further episode. Goodbye. Thanks.